Okay, so you use the brine, it falls through the sea. If you throw it away, it's ridiculous invention. The brine is lost, and I don't know how much it is. What I'm not saying. I had a look, but it's like you'd spend, say, 100 kilowatt hours at least, maybe to make the brine, and for the sake of argument, you might get a kilowatt back. So the problem with it was that it was rubbish. This was embarrassingly rubbish. So I remembered my GCSE chemistry class where we diffused salt and seawater and stirred it. So the next part of the invention is the brine has fallen to the bottom of the sea. Without leaving the system, it goes into a container, and that container is joined to a hose. The hose goes back to the surface, and there's another container with an equal volume of brine to the volume at the bottom, and the brine will, so that water is empty, and the container is not emptied. You have to imagine it's already in motion, so it's like it's an engine, it's already full of fuel, and this is how it would work. So there's no vacuum, and the water goes, the brine passes in the container, and the container was less concentrated, so the brine moves into there, and it shares its concentration with the hose, and the concentration moves into the hose and balances out, so it's like equilibrium. Brownian motion, diffusion. And there's a series of containers, so there's more than one container. You can have any number. It's like a Mensa game, or GCSE maths project, which is why I treated it. And you move the brine across at the bottom, preferably across and down, and you gradually take the concentration off the brine from the concentration that's fallen, and you suck the concentration, basically like suck. It's kind of like sucking the concentration out of the brine by sharing it with another quantity of less concentrated water. So it could be seawater, it could be also brine itself, but it's less concentrated, so the concentration moves from higher concentration to lower concentration. And depending on the volumes, you can lose most of the brine can be lost. So you end up with as little, pretty much as little as you like, but then you have the expense of the tower that goes to the surface. And when I was thinking about this, I happened to be thinking of it as very tall, so thousands of meters high. I'm not sure that's necessary, but at all. But it's certainly an exciting, fun thing to think about. So just say it's 1,000 meters high. You won't necessarily want to carry on having 1,000 meter high, but they probably aren't expensive. If it's hose, it could be how much? 2 for 6,000 pounds of hose from China or Par Group or something like that, which is the same kind of hose as would use in the OTEC. So it's not actually very expensive. Yeah, so that's what I was thinking. I'm just full by, because obviously there's Third World War just breaking out over energy. And interestingly, Ukraine, the Crimea, so it's Russia, strictly speaking, there's a nuclear power plant there, and there's 2,000 metres off the Crimea water depth. And the interesting thing about a nuclear plant is that you could do cogeneration. You produce power, you'd have waste heat, 10 to 1 apparently, so you'd have 10 kilowatts of hot water to every 1 kilowatt of electricity. So there's tons of waste heat, more than enough to desalinate water. It's called cogeneration. And that's without interesting things like low temperature thermal desalination or multi-effects desalination, either of which is used in hot waters that's still hot to warm up the water in a vacuum to lower the boiling point so that you can very cheaply produce drinking water normally, but now this is you might be able to make brine as well. In case you hadn't, I mean, presumably, and I think this is the skill that I need when it comes to these presentations, like, presumably you would have whack at this. If you really concentrate the tower, and on the paper you can do it up to 99.999999% of what it was originally, as long as you use more than lots of batches, like an engine, so it's not just one batch, it's hundreds. You can kind of take all of the brine out of the system. So I think the problem with talking about this is that it depends what do I mention next and which one were you thinking about. So at the moment the brine is diluted up to a degree, say like most of it, and then what do you do with it? And a while back I was at the point where you either toss that, you do release that into the sea, or you could pump it back to the surface, and that's why I'll leave it for now. There is something else I reckon you can do to it which makes the whole thing even more remarkable, but I'll just leave it there. So just at the moment we're throwing away a much less concentrated brine that we were into the sea, or we're pumping it back up to this the surface to stop it from becoming particle chemical waste, which of course it is. So what have we done? We've restored the potential energy. The only who think of the sea, so you can, or as long as you can, I do believe that you can. Here's the problem. This is why I left this project to work on something I know works, because so you should have a tower full of concentrated brine. We assume that diffusion couldn't work, and that we're going to have a tower full of brine in the sea. This is the way it was. And so as long as that's true, and it looks like it would be, the diffusion does go against gravity, so perfectly. So it ignores the gravity utterly, as long as it's not a saturated solution. It ignores gravity utterly, and it's a solution. So you don't go, it's in the water. So you restore the potential energy. So imagine the first time I used 10 kilowatts to make a batch of brine. And by diffusing it back up in the tower, I've used, well, anywhere up to nothing to restore the concentration of brine. So, and then I can use the brine to fall again. So instead of it being 10 kilowatts to 100 watts for one falling, it becomes 10 kilowatts, 200 watts. and it isn't lost the second time round either. So it's continuously recycled. So the system is letting the brine, even if you use desalination with electricity, which I'm not suggesting you do, you would catch up. So you'd actually begin to have a similar amount of brine